Okay, so here are a lot of the gas equations we've talked about. Who wants to memorize them all? I don't. You might think you have to memorize all these, and maybe your teacher has even asked you to do that, but you don't have to, because I'm going to show you an incredibly useful trick in this video so that you will never have to worry about memorizing all these guys. Here's how it works. All you have to remember is the ideal gas law. PV equals nRT. And it kind of has a nice ring to it, so it's really easy to stick in your mind. You remember PV equals nRT, and you can use it to get any of these other gas laws whenever you need them to solve a problem. So we can put all these guys away because we don't need any of them anymore. And I'll show you how to use PV equals nRT for this trick. So let's say that you're given a problem like this, okay? We have a before and after, we have pressure and temperature are both changing. So we look at the variables we're dealing with, as I just said, pressure and temperature. And what I want to do is I want to take PV equals nRT, the ideal gas law, and rearrange it so that the variables I'm interested in, pressure and temperature, are by themselves on one side of the equation. Doesn't matter which side it is. Okay, so pressure and temperature. So to get P and T by themselves, I'll first divide both sides by V here. And then V over V will cancel out. So now I have P equals nRT divided by V. And I want to get T on the other side of the equation so it can join P. So I'll divide both sides by T. And now T over T cancels out. And I'm left with PT, P over T equals nR over V. Okay, so we have P over T on one side of the equation. Now it turns out that if something is on one side of the ideal gas equation, you can double it on the other side, doing a before and after thing. Here's what I mean. We can take this P over T and turn that into P1 over T1, there's a before, and then we double it on the other side, equals P2 over T2. What we've actually just done is we've created Gay-Lussac's law. But I didn't have to memorize it, and all I had to do is take PV equals nRT and figure it out from there. Okay, let's look at another example. Here is one where I have an initial pressure, a final pressure, initial volume, and final volume. So the variables that I'm interested in are pressure and volume. As before, I want to rearrange the equation so that I have pressure and volume by themselves on one side. That was easy. The ideal gas law is already written so pressure and volume are by themselves on one side. Okay? So what we do now is we double this PV on both sides of the equation, doing before and after. So P1 times V1 equals, double it on the other side, P2 times V2. And now I can plug in my variables and solve for V1. And check it out. What I did was I used PV equals nRT to come up with Boyle's law. Okay, you're probably getting the hang of it. I'm going to do two more examples, but if this already makes sense, go ahead and move on. Now, one question that I do often get is, how do you know which variables you want to rearrange the equation for? You know, teachers and textbooks don't always ask questions where they just say V1 is this, N1 is this, and so forth. So if you're given a word problem, it can be a little bit trickier to find out what variables you're using and whether they're V1, N2, or whatever. So if you're having a little trouble figuring out what the variables are, watch my video called Which Gas Equation Do I Use? And that will tell you how to read a word problem and figure out which of the variables you're working with, okay? So this one, we're going to be using volume and moles. So we want to rearrange the ideal gas law so that I have volume and moles by themselves on one side, okay? I will get rid of P so that I have only V alone on this side. Divide both sides by P. And then I have V equals nRT divided by P. And I want to get n to the other side. So I'll divide both sides by n here. Cross that out. And then I have V over n equals RT over P. I have this guy by itself, so let me double it before and after on both sides of the equal sign. V1 over N1 equals V2 over N2. And what I did there was I came up with Avogadro's law. One more. This is for one that's a little bit trickier. I have a before and after here where 3 variables are changing. I have volume, pressure, and temperature. So everything that I've been doing up until this point has just had 2 variables changing, but it's no big deal. You can use this technique for any number of variables. So volume, pressure, and temperature I want to get on one side of the ideal gas equation. So I already have pressure and volume here. So how about I divide both sides by T to get them all together here. Cancel this out. And I'm rewriting it, but it really doesn't matter what's on the right side here. All that matters is what's on the left side here when we get these together. So I now turn this to P1 times V1 over T1, double it on the other side, equals P2 times V2 over T2. And that was the, where is it here? That was the combined gas law, but hey, I didn't have to memorize it. So that is how you can use this technique to come up with any of the gas equations you need and not have to worry about memorizing. But you will have to be able to read a word problem and figure out which are the variables you're working with. So again, if you're having trouble with that, watch that video that I talked about earlier and you should be all set.